do. So let's get started, right? Uh, so what's there today, right? Uh, this is another picture. So last time, I was showing Spot Me with one of the Red Hat colleague who is an author. I don't know. Don't care if you can't see, right? Uh, so last time the picture was with Graham, and that was when last 2019 when the Red Hat Summit happened. I made sure met him because every time he come to India for DevConf, we have done some work together, and we have also started an iVentura platform. Got inspired from him. Uh, this session picture is the 2019, Ansible Summit, which Prodavance did host, and we had our stall, and this entire team did a fantastic presentation. So if you can trace some people, the person a South Asian guy, beside Anirban. Anirban is sitting on my right hand side. He's a product owner of Ansible, and Nicholas Chia is behind him, wearing a red jacket, and there are rest of the folks from Prodavance. The other picture is of Ajay, who is my co-presenter. Ajay is a solution architect, worked with Red Hat. His team is called Red Hat One. It's a very qualified team in India, and most of our employees work in Red Hat, are the solution engineers and architect. And Ajay is going to be a co-presenter with me. Okay, and Twitter handle is Tech Prodavance. So if you want to tweet any controversial thing, don't please follow. If you want to follow, unfollow, or want to say something, please do tweet there. Okay. Uh, Coming to our agenda. So last session, what we discussed, we will just do a quick recap, and understand and get our understanding reconfirmed that what is container, what is a container registry, how container work, how container expose the services through the port, and the difference. I remember Mitali. I don't know whether she's there or not. Okay, the node port, and we also talked about several other features related to container, right? And my promise was that was the intro, and we just touched OpenShift. But today we will be spending a good quality time discussing OpenShift architecture. So you see OpenShift 3 and OpenShift 4. So all the guys, those who have been on OpenShift 3, I come across some customers who are still on OpenShift 3. It's a very stable, platform, but they could upgrade only until OpenShift 3.11, right? Pradeep, we could see you. You can turn off your camera, and you're wearing mask. That is also good. So OpenShift 3.11 was the last 3.x release. So I'm sure some of you might have worked on OpenShift 3.9 or 11, or might have upgraded all the way to 3.11. So we will talk about OpenShift 3 architecture and core pieces. And I will also take you to OpenShift 4 because you must know what is OpenShift 4, right? And we will do OpenShift 4 administration because a lot of you have reached and said that fine, Deepak. We know we can jump into OpenShift. We understand Docker. We understand Pod. We understand Podman. We understand to manage, several, pods in OpenShift, or in Kubernetes. So we understand, but we need work. We need, some real time exposure. So what I and Ajay have done is, okay, we have created this kind of agenda so that you get to learn OpenShift administration tasks. This is how easy it is, right? Okay, a lot of people bring a lot of perception that I need to be a command line guy. I must know Linux. I must be very, very good in Linux. Okay. I must know Kubernetes to learn OpenShift. No, none of these things are required. Okay, and as I told, my training company, Complete Open Source Solutions, they do run regular OpenShift classes for training and certification, and it goes all the way up to 90 to 100 hours of training. So I must be having some trainers who will actually pop up when the questions coming up. So please, reach out to them if you need any kind of training. We will talk about what training you can pick it from their catalog. But this particular session is going to be more interactive, more in depth, to understand the architecture, to understand how the enterprise scenario works, how a multi-node cluster work, how a multi zone cluster work, and how we can do the operator tasks. So we have overview to the operators as well. Um, the chat box is open. Please post your questions, and we will have quiz. We'll have quiz. Dinesh is responsible to run the quiz, and we'll see who all do good. Last time, very few people attempted the quiz. Come on, guys. Okay, you need to bring that courage, right? And it's going to be confidential. So we will be, putting you on spot and asking you to participate in a quiz as I cover the architecture topic and switch to the demos. And please be sporty, don't hesitate, and nobody would know, okay, what is your answers, but we will definitely appreciate, okay, when you are doing good, right? I might send some Prodevance goodies, or Red Hat goodies to you, or some discount on training. It all depends, but please make sure that, okay, you participate well. Yeah, Sham. Okay. So OpenShift architecture, right? Why did I mention OpenShift 3 high-level architecture? The reason is, from the architectural standpoint, OpenShift 3 and 4, you will not find a lot of difference, except the new features. But the way it is being built, the way it is being operated, you know. Um, yeah. So Falgun, yes, we can talk about how to get your Minishift working, but definitely this is something which we can introduce so that you will get your OpenShift on your desktop or laptop, right? Uh, okay, so coming to the OpenShift architecture, without much ado. Uh, so all of you understand that OpenShift is a container orchestration platform based on Kubernetes, right? And what does it bring? It brings the benefit of both operations and development. It provides the developers and IT organizations a cloud application platform. Note, it brings, even though it is on premise or it is on a hybrid cloud, it brings the cloud orchestration application platform, right? So if time permit, I will put you across the CXO, the CIO, the CTO, the dev manager, what kind of question they come across. So that is something which will definitely help you when you are dealing or discussing with your customers or your colleagues, or when you are participating on the interviews, right? uh, so we will talk about what kind of questions you might come across to justify why do you need a container application platform, right? Um, and what minimum configuration you require, right, to run such an overload. What minimum configuration you require, what language it support. Okay, does it support applications with Java? Does it support application with Python? Does it support application with Ruby, Node.js, Perl, PHP, .NET, and many more? That means the world of applications, which is the information technology world, they are built on these programming constructs or programming languages. And if you are giving or bringing an application platform for developers, so that they cut down the development time, then that's a fantastic thing. Okay, I will keep a session for only DevOps, CI/CD. That's my promise. We will do some real-time application deployment, source to image, build and deploy, and zero touch service, function as a service. So these are the things which we will do in another session. Today it may not permit because we will be focusing more on administrative tasks today, but we will keep a session for this, and we have 4 more sessions or 5 more sessions which is still coming up. So please follow us until you get over all this. Openshift is built on Kubernetes, that we have discussed. So for you to give you a very good understanding what is Kubernetes and what is Openshift, in this diagram, what you see in blue color is Kubernetes, what you see in green color is Openshift. So what you are seeing, the blue color stuff, right, is Kubernetes. There are Kubernetes service, etcd, and there are infrastructure services, and there are monitoring services, which is in the blue color. So that means, okay, that these are the Kubernetes services. And the green one, so many people ask this question, why OpenShift? Why do I need to spend on OpenShift? Because it is a Red Hat product, but it has something called OKD, which is yeah, blues are native KTS services. So you can go with OKD, if you are not spending for your product, for your development workload. But this is the easiest way, to understand. OpenShift Container Platform control plane is available to be deployed on Red Hat Core OS when it is, OpenShift 4, right? So Core OS is something which Red Hat brought last recently, and that is why the OpenShift 4 became enterprise available, can be deployed on Red Hat Core OS and or Red Hat Enterprise Linux. So that means Red Hat Core OS is available for all OpenShift deployment, but it is not for general use. That means you are not expected to pick up Red Hat Core OS for your general application purpose. It is meant only for it's, you can say it is a customized Red Hat Enterprise Linux, Enterprise 8 Linux, meant for only OpenShift. So it is most lightweight, and it actually brings a lot of operational utilities, which is fit for purpose in Red Hat OpenShift. Red Hat CoreOS is FIPS compliant, which many customers ask that is this is going to be a platform which is FIPS compliant. You can do Google what compliance criteria it meet, but this is must for all production workload to run. And it meet your security, privacy, compliance, governance requirement. Please understand, when you are running a payment workload, when you are running data workload, when you are running customer critical information, these compliances must. Okay, these compliances must, and without these, you cannot take it to production. I also get this question that uh, can I do OpenShift installation, right? We will do a session only for installation today. If time permit, we will talk about the um, the prerequisites for OpenShift. A lot of people don't organize themselves for OpenShift, so we will talk about the prerequisite, and those prerequisites you must understand, okay, before you proceed for OpenShift installation. But let's classify the OpenShift installation. So it is IPI, and it is UPI, right? If it is an integrated experience, right? So for example, you want to do a full stack automated OpenShift installation, which is integrated OpenShift installation, where you have got Amazon, you have got Azure, you have got VMware vSphere, you have got OpenStack, you have got bare metal, and you have got Red Hat virtualization. So you have got KVM, VMware, Amazon, Azure, and bare metal. Can I do OpenShift installation in a public private cloud, which is full stack, fully integrated? That means you have not got a lot of options to customize your the base infrastructure. But which one is most popular is the UPI. What happens? A lot of customer has already invested on their data center, right? And when they have already invested onto their data center, for example, VMware, and VMware, when you have, and obviously the VMs got created, right? So let's say you have got VMware vSphere, right? And it is already a pre-existing environment, and the admin is giving you only the VMs, right? Before you start your, or you have the KVM, and the admin is giving you the VMs, right? So when you have pre-existing infrastructure, whether it is on AWS or Azure or VMware or on bare metal, you want to do a installation which is disconnected, then you should go for UPI. So please post your questions related to IPI and UPI, but you write down that, okay, integrated platform installation, which is IPI, the most complicated, and most organization go with UPI because it gives you to deal with the pre existing infrastructure. OpenShift 3.11 was the last release, and it support physical machines, virtualized infrastructure, virtualized platform like Red Hat virtualization, vSphere, Hyper-V, which is Microsoft's virtualization platform. It is also supported on OpenStack, so you can have OCP on OSP. You can have OpenShift on OpenStack. You can also have it on Amazon, Google, and Azure. Can it be installed on x86 hardware? Answer is yes. Can it be on IBM Power Series system? Answer is yes. So except the Spark and IBM AX, everything is being mentioned here. and it is built on the Kubernetes engine. And many people say that it's a wrapper on Kubernetes engine. I do not buy that because it brings quite a lot of additional benefits rather just a wrapper. So we will see how administratively you can handle these kind of things, and you should do some little research about this. I'm sure, okay, you will get a lot of material related to the features, and I don't want to run you taking you through the different slides. But what does it do? What are the core terms, right? It runs on Red Hat Core OS, and it runs on Red Hat Core OS, and the general terminology, like you will be dealing with the two kind of nodes. One is worker, another is master. So let me use my whiteboard. I'm more comfortable on a whiteboard than these kind of um, stuff. So do I have OpenShift? I'm sure. Okay, so let me take a new one. Okay, so here you go. So what I'm doing is I'm dividing the whole OpenShift into type of nodes. What are the type of nodes it will be dealing, right? You have got masters and infra. Okay, you may ask this question: is it must or optional? It is optional. That means you can have OpenShift with just master and worker. Yes, 3.11 was the last release, and 4.2 is the so if you are looking for an UPI, then it is 4.2. Okay. So can you do this? Answer is no. So you have to stand up 4.2 separate and do a migration, right? Uh, and what are these nodes? Nodes are nothing but the OS VMs, means VMs with installed OS. Okay, and what OS is being installed? RHEL. So that is why people say you must know RHEL, uh, CentOS, CoreOS. So you can install a master uh, if the operating system is RHEL or CoreOS. Okay, so what master do? Master manage, right? So master manage the cluster, right? This is fundamental stuff. So last time, as you guys know, the container, those who have not attended, for them I'm saying, okay, if you're talking about a container, it is actually created out of an image. Image is nothing but a template or frame. Okay. So the application binary, the code, the developer, we talked about what? Java, Node.js, um, Node.js, and .NET. So all these PHP, you know. So this code okay, is actually built, right, onto this image, right? And so image, you can say it's a binary, it's a build file, right? And this gets deployed, which creates a runtime called container, right? I'm sure this much of fundamental is good enough for all of you to understand. Now, if I have more container, right? For example, I will have a front end. Anything I'm saying, we will demonstrate today. Okay. So please have patience, right? So if you have a front end, let us say a HTML, JSP, or PHP, container, and backend is a MySQL, right? So you can, the way OpenShift works is they call this as a pod. So pod is one container or two container or a combination of more than one container. Okay. So this concept is unique, right? This concept is unique because if I say this is pod, so OpenShift operate in terms of pod, and what it does, it actually consists of co-located group of containers with shared resources. So they share the resources. Okay, so when you are impacting a pod, and pod doesn't mean multiple container. Pod can also be a single container. Okay, or pod can be multiple container, right? uh, so it may happen that these pod talk to so this container talk to each other within a pod, right? But in OpenShift, this is the smallest unit. Container is not the smallest unit. Container is within the pod. So pod is the smallest unit in OpenShift. Please understand. Okay, this can be a web server, this can be a database server, this can be a web server, this can be an app server, but pod is the one, okay, which has got a group of containers, right? Hope all of you understand. So what happens um, in a real scenario, as you know that, okay, if you have to host an application, you need a room, and that room is nothing but a VM. Okay, and so these are the nodes. Okay, and in OpenShift, we call these nodes as compute nodes as workers. Okay, and what did I say? I said a pod is nothing but more than one containers. Okay, and this is a pod, and it's a runtime. Okay, and how do you address the pod? With the IP. Okay, so pod will have an IP. Okay, so you are seeing this as a pod. Okay, and you can have as many pods. Ideally, we see about uh, uh, 500 pods in a worker node. That depends on the compute capacity, but please understand that um, a, a a worker node can have hundreds of pods. Okay, and a pod can be one or two containers. Okay, so this is a pod, right? So the complex applications will take multiple container in one pod. Otherwise, okay, you can have one container per pod. So when Ajay is going to take charge, what he will do, he will say OC. So OC is the utility, right? And he will use a simple command, OC get pod, right? So what does it do? It will list the pods, and if you say that from this particular namespace, okay, it will get you the pods from that particular namespace. Namespace is a project. So what is a namespace? it is nothing but a project. Okay, so what does it do? This command will get you the pods which is running, right, which is running in your particular project namespace. And today it's a big day for all of us, right? Okay, today we will discuss how the namespace can be managed, how the authentication works, how will you secure the namespace, how what roles you will map onto the namespace. All these things we will discuss today. So have patience, right? Have patience. Stay. Right. Now, if I have this particular pod, and I have this particular pod, and I want to access this pod because I'm on internet, and I'm using a HTTP browser, and I'm saying that, okay, my site. So to access this my site, right, I will not be able to access this pod unless until I have a service layer. So what do I need? I need a service layer to access these pods. Okay, because pod gives an internal IP. So this IP is internal. Yesterday I was in one of the customer call, and the call was to discuss how we can optimize the public IPs in Azure or AWS. Most of you who have been working on Azure or AWS, you launch a application or a VM, hosting that application. To access that application, you need a public IP, and they are paid IPs. And the VPC which has been given to you, it has got limited IPs, right? You cannot have thousands of IPs, right? So question is, does OCP support on GCP? Answer is yes. You can have OCP on GCP. Okay, so anywhere, if if you got the VM, you can get the OCP. Okay, so I got distracted. So the service layer is actually the one which make so if I say this pod and this pod wants to talk, then this service pod. So service is also a pod, right? So the service pod will bridge between the application database pods. Okay, so the front-end service connects to the database service using a service. Okay, that's the best definition. So what it does, it organizes itself that you have a pod. Okay, you have a application pod or LB pod, and you have a service pod, and you have got multiple web pods, DB pods, app pods. So the service pod is actually act as a bridge between, and as you know, each has got internal IP. Okay, please understand, right? So so this is the way it works, right? I would say that, okay, this is the simplest way ever you can understand. Now you have this is a pod. Okay, and can I give a name, tag? So we call this as a tag, right? So what is a tag? You can organize, you can say that, okay, so PD dev, right? So so you can tag pods with a label. Okay, and so that what happens, the services use the label selector to identify pod they proxy to. So to which pod, so if you have so many hundreds of pods, and this particular service pod, how will it identify, so it will identify based on the tag. So or the labels. Okay, and in technical term, these are nothing but the key value pairs, right? So in the config file, these labels are nothing but the the key value pair. So that is how it is being understood, right? So what doesn't change? The labels do not change, right? Now, so what happened, I got this management discussion like service layer, while the pods are running in the worker node. Okay, but uh, if I have this is getting complicated, so what should I do? I will take a lead and I will say that I have got uh, apology, my drawing is not that good. Yes. So as you know, there is a rule of three, right? So you can have master, zero, and today we will see all this. We will see. Okay, master. So you can have multiple masters, and in the previous architectural diagram, I told you that the orchestration activity. So what master do? Master orchestrate worker. Okay, so master orchestrate the worker. And why we call it as three master? You can use the chat to answer, right? Because you are talking about HA, high availability. So if you're talking about a platform which is always available to the developer, then without high availability, you cannot guarantee, right? And we are talking about FIPS compliant, all that. So if you need high availability of the platform, then you will go with the three master, right? Rule of three. So
Sorry
this
to
is,
interrupt. I have
yeah,
a question here.
yeah,
Uh,
please.
uh, I heard like actually we can have only three master maximum of. What is the
Mhm.
thumb rule behind that? Why can't we have four or five, six? Worker nodes we can have maximum. We can have as many as we can, but
You
master,
can have worker nodes in 500s.
yeah. But why master is limited to only three?
Okay, so I will get into that question answer, but why rule of three, right? I'll get into the master, topic, but the rule of three. Please understand that all of you understand a data center. Okay, within a data center, you can have these are racks and these are rack mounted servers. Okay, and this is the top of the rack, um, switch, and these are the servers. Okay, so each data center you can have, so you can have OCP in each data center. These are independent. Okay, can I have a OCP? Between two data centers? So this is called stretch. Okay, so this design is absolutely a no. Okay, so this design is not allowed. Practically, is it possible? Answer is yes. That means I can have two masters here, and I can have one master here. And if this master goes down, can I create one here and I can maintain the quorum, right? So anybody understand the cluster quorum? Okay, we talk about three, right? So this kind of thing is possible if you have less than 3 millisecond, communication between the data center. So within the data center, it is always preferred. So not across the data center. So that means in a data center, you can have three masters. Okay, 3 master in a DC. Please understand, or in a availability zone, right? So it's not like you so what it says is you spend less on and the amount of services you require you can handle within 3 masters. Now the question, some guys will come back and say, oh, are you saying I cannot have 5 master? I would say you will have 2 infra. So what you can do, you can give some of the responsibility to the infra node. Okay. So your number of investment towards the master is max 3. Okay. To maintain the quorum, 3 is enough. And 2 infra, or you can have X added. So you can have more infra nodes. Can a worker node be infra, transition to infra? Answer is yes. So so you can. So these are the things which we will discuss much in detail during our demo, but hope it make you understand that I think Vijay was asking this question,
Yes,
that
sir.
in rule number 3, so rule of 3, you to maintain the quorum you require 3. Now if you need 5, you have 2 infra, right? So you need not have more masters. Okay.
So one quick question, sir. This is Prashant. Hello, sir. Hello.
Yeah, Prashant, you can use chat to get your question flow, and
Okay.
I'll pick up the questions, right?
All right. Okay. Yeah.
Okay. So I just don't want you to hold your question. Please, put your question on the chat. Okay.
Okay. All right. Yeah.
So you also might heard another topic called etcd. This is a core Kubernetes service. Okay. So age today we will be talking about role-based access control, because to access Kubernetes you need role-based access control, right? So the rules to get you access onto the roles, right, and application environment and non-application data like the logs and all that, who is responsible? Etcd is responsible, right? So this is a critical service which actually distributed across master, and this particular service is one of the core service in OpenShift. Okay. um, then am I missing anything? Yeah. So what other core services? Okay. So you might have remember that the blue color ones are the Kubernetes core services, which are the default services, right? What are those? API service, okay, scheduler, right, um, and cluster manager. So so these services are running in the master. Okay, and these are the Kubernetes core services. Kubernetes core services. Okay, it provides Kubernetes provides a API server and and a scheduler and cluster manager. So these services are improvised by OpenShift getting you. So this service is improvised, called OpenShift API, right? Similarly, OpenShift Lifecycle Manager, right? Similarly, um, OpenShift gives you a web console. So anyone ask you this question, that why, when you have Kubernetes, why do you need OpenShift if it is just a wrapper? You just tell him that this motivate me. So you heard about several other things today, but this is one incentive for you to go with OpenShift. So apart from the Kubernetes API service scheduler and cluster manager, you have got some of these additional things. So these are the features. These are the features which make OpenShift more popular. And you today see, because you must be thinking, oh, it's just feature. No, we will see how conveniently you can manage OpenShift without having any Linux experience. Some of the people will say, oh, so Deepak is saying without having Linux experience, I can manage OpenShift. Answer is yes. Because if I give you a web console, right, you'd be as stupid or dumb like a Windows guy, click, 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 and you will do the work. So you don't require, Linux. But yes, can you be a level 3 guy of OpenShift? Answer is no, because you must understand the Linux fundamental. Okay, so that is why we recommend people to go with Linux. Okay, I will talk about what are the prerequisites to understand OpenShift. But yes, you can start your journey. If you have not started today, then you will never start. So don't hold yourself. You can get onto OpenShift without knowing Linux. Also, it is fine. Okay, so the master, where is master? Yes. So this gives a HA, right? And these are the workers. Okay, these are the workers. So what master does, it collaborate with the workers. Okay, and it coexists, right? So it actually gives you some of the functionality or the features, okay, which I was talking about, and that makes it more crucial in a production scenario, because I require monitoring, right? I require logging, right? Because without these features, I cannot run a production environment. And I see somebody's asking, can I understand the what do you call networking in OpenShift? Answer is yes. Last time we talked about the pod port, node port, and all that, but we will also discuss the networking. And DNS, it's very crucial, because it actually point to the nodes by its fully qualified domain name. At the same time, it also gives you a service, and service can be point to a URL can have a dynamic URL, right? So you require the DNS mapping to be done. Okay, and there is kubelets. Okay, so these are the processes, okay, which actually help you to minimize the outage, minimize the disruption. So kubelet help you to minimize the disruption. Okay, then we also talked about this API service, right? OpenShift API, or master API, right? So what does this API give? These are the endpoints. So anybody who understand uh, endpoint can understand API. API is actually way to access an endpoint. Endpoint is nothing but a resource. Okay, so to interact with the system, it gives you the APIs, and using the API you can access the system, right? So if you have to do some work, so those conventional client server model has gone. So to access that particular resource, you require the access to the endpoint. Okay, and all API requests must be secure, right? So it's SSL. So API is the medium to access the endpoint, and securely access the endpoint. Okay, so obviously you require SSL to make a secure connection, and you also require authorization, right? Otherwise anybody can do work, right? So you need only the legitimate people to deal with the administrative tasks. So today we will show you the administrative tasks. So if these are all resources, and there are so many resources, right? Okay, these are only tip of the iceberg: monitoring, logging, SDN, DNS, kubelates, and there are application pods. So there are so many resources, and the API manager gives the way to access those securely with authorization. Authorization means role-based access, right? Authorization means what? Role-based access control, right? So we will see, first we will create a user. To get a user also, you need an authentication mechanism. So get a user also, you need authentication mechanism. So today we will see what are the different authentication mechanism is allowed, right? It allow you HT password, and it allow you LDAP, it allow you single sign-on. So authentication, authorization, SSL. So using this thing, okay, your access to the resource can happen, right? And can I do CI/CD with these resources? Means yes. So CI/CD is not meant for only application. Please understand, CI/CD is not meant for only application. It is also meant for cluster management, right? So and now let's go back to the picture. So what will happen if one application is a combination of these three pods, right? And you have got a very unfortunate situation, and this pod crashed, right? So somebody must be responsible to do health check, okay, and scaling. So what does scaling means? So if somebody is going down, right, you will have another person scale, right? So health check and scaling are complement, right? And please understand that this cannot scale unless until there is a config associated to it. Please understand that you are creating something which is desired, and the desired thing. For example, you think at your home, you have invited 10 guests and 5 more guests came, so you needed 15 guests to be served, but you have ordered only 10 packet of food. So what will you do? You make another 5, or let's say you have served drink, right? So you have some drink being prepared for 10 guests, and you need 5 more drinks to be created. So what do you require? So you require the configuration of the drink so that you can create 5 more drinks, provided you have the resources. Resources means is raw material, right? So similarly, if you have the compute, this config management help you to scale based on the health. Okay, so please understand that today we will discuss how OpenShift do an effective config management. We will do all disruption. We will see, we will go and scrap the entire config, but since it is a static file, it actually recreate as it is, it was spoiled. Okay, so when something fail, remediation of failure, right? So remediation of failure can be done based on these config. And who is doing all that? Who is doing all that? Master. So now you understood what is the significance of master. The master do monitoring, logging, OS tuning, SDN, DNS, SDN, the routes and all that, right? Services which we talked about, the kubelet, and scaling, config management, CI/CD, remediation of failure, right? So if the pod is keep on failing, so some service is unhealthy and it is keep on failing. So when it fails, it recreate. When it fails, it recreate. Okay, or it was not started. So what it does, it actually create a healthy thing for you based on the config. Again, I repeat, based on the config. Then you have got something called scheduler, right? So scheduler, what happens? I think someone said that, okay, how many worker I can have? Worker can go n equal to 10 or 100 or 500, right? I have seen environments, okay, which goes to maximum, right? So what happens when this particular worker goes down, right? Or you want to launch a new pod, okay? So the scheduler actually helps you to increase the pod or increase the worker. So scheduler helps based on the resources. Anybody who has studied OpenStack also maintains a scheduler, Nova scheduler. Similarly, here also you have a scheduler who actually responsible for the application high availability, spreading the application across multiple worker node or between worker node, create new worker node, so placing the pods, you can say somebody who's responsible putting the pod in a desired worker node is what the scheduler does. Then what happens when you are talking about one worker node, you are talking about another worker node, so you can have a logical grouping of the worker node, so you can call that as a zone, right? So today we will see region, zone. So you can have a data center, okay, and that can be a region like US East, right, or India East. Availability zone within the data center, you can have a availability zone, right? So what happens, because if I am scheduling a pod in a availability zone based on the customer type, right? So I can have different networks. So CIDR, okay, the network guys understand that if it is in the same CIDR, it is called the availability zone, right? So that is another concept which we will also see or understand or demonstrate. Did I miss anything? Okay, so what happens if you have a desired state, that okay, my pod count is going to be, so this is third, this is second pod, and this is one pod. Okay, let me say that this didn't exist. So if I have a desired state of always maintaining 3, right? So this kind of concept is called as replica set in Kubernetes. Okay, in Kubernetes it is called, and in Openshift it is called replication controller. Okay, so if you are on Openshift, it is a replication controller which is based on deployment config. right? So in the deployment config, if you have mentioned count equals to 3, so what happens, the replication controller will make sure that it will actually be giving you those many pods at any given point of time. Okay, so that is something also we will see or demonstrate today. uh, Anything else, yeah. um, so those who are coming from old Kubernetes, what do you call 3.x. So 3.x, what you were doing, you were defining all your requirement in the templates or scripts, right? Playbooks, right? So this was difficult. What is easy? Operator. I'll give you one scenario. Let us say you need a single sign-on, right? So what will you do? You will go for a key clock, JBoss SSO, right? Or WSO um, 2, right? JBoss SSO, you require service. So traditionally, to do this, you required 3 VMs of JBoss, and you were setting up a JBoss SSO, right? Now, with just one operator, within seconds, you can bring up the SSO as a service, right? And these need of templates, script, playbooks are gone because the operators are certified. Okay, so the certified operators are available from Red Hat. Okay, but can community also give the operators? Yes. In fact, the Openshift installation is being done using operator. So the community operators are non-certified operators. Okay, so can an organization have its own operator? Yes. So you can have your own operator, right? But Red Hat is bringing you the certified operator. So apart from the features like the service level we saw, like OpenShift API, OpenShift lifecycle management, web console, and we also talked about the other features what CoreOS brings, right? Apart from that, one of the beautiful thing which Red Hat gets you is the certified operators. Okay, and these are the automation software, like SSO, Ansible, all these are mix of things. So you can say that, okay, I can easily work with an operator, and so job means Naukri, right? So if you are a OpenShift engineer, please learn how to create, how to design operator, okay, or how to create your own operator, right? So you would require certain skills to build or develop the operator, right? So you must know that CRD, custom resource definition things, so um, which you would learn over a period of time, like operator SDK. So there are development toolkit which the operator developers use, so you can build your own operator lifecycle management. using operator SDK with design principle of CRD. And you can monetize the operator. You can meter and monetize. Meter, monetize. See, if you are, selling the operator, you can um, say that, okay, how many operators are being used, okay, how many times it is being used, and based on that you can also fix a dollar value. So this is called operator framework. Okay, and this particular framework is becoming so popular that you have a community called operator hub.io. Okay, so please go to operatorhub.io and you will find all hundreds of operators. You will search and you will get it, right? And Red Hat has the certified operators published, right? Okay, somebody asked networking. So how OpenShift work? As you know, the pod, IP is internal IP, right? And pod is the smallest, service to be identified, and a pod can have C1, C2, more than one container, right? And it's a port, right? But from external, you want to access, right? You need a virtual switch. So the pods are connected using a virtual switch, right? So the virtual switch technology is coming from OVS, Open vSwitch. Okay, so this virtual switch make these pods connected, right? Uh, I'm telling in a very simplified way. Okay, and to talk to the pod, as I said, I need a service pod. Okay, I need a service pod. I need a route pod, right? So these are created by whom? These OVS technology. So OVS gets you the DNS pod, right? The DNS namespace, service, route, right? A switch. So this is how it works, right? And anybody who understands the IP tables can do better troubleshooting, because it uses NAT, network address translation. So the pod or pods, right, with their CIDR, which is local, right, and the service as a public IP. So this is NATed. So what happens if you want to go out? Then you will have SNAT. Okay, and you're coming in, right? So this IP is pointing to this particular pod based on the labels, right? So this is called DNAT. Okay, so it uses SNAT and DNAT to manage the network communication. So you can please understand OVS, router, right, are the ones which makes the SDN work. So if you want to dissect the OpenShift SDN, I forgot another term called DNS. Okay, so router, DNS, are the OVS concept which actually help. So to best example is, for example, I want to launch my app. Okay, so what I would say, I'll say https colon double slash my app, right, dot let us say pd prodevance. Then I will say OpenShift example, right? So this is my URL of the application. Okay, so this is called uh, the proxy URL, proxy service. So it's a proxy service is a pod, right? And it is pointing to a IP, right? Service IP. So this is done by the DNS. Okay, and multiple pods are falling under this. So that's being done by the routes. Okay, so that is how things work. Okay, so I will let we will see more practically than theoretically how the service uh, pod work. We will see that practically. Okay, so now we will do just pause here and see that, okay, if you have any questions, let's see, we will answer them using the demo, right? uh, those who are new, you have to go one at a time. So first get your understanding clear. Ranjit, how much knowledge of Kubernetes is required? Does a sysadmin need some developer knowledge as well? As it is good if you have a developer knowledge, little development knowledge is required. Okay. Uh, yeah. So Ajay, so can we do some demo?
Sure, Deepak. Yeah. Hello, everyone.
Yeah. So I believe we discussed a lot of these things, right?
Yep.
Operator, did I talk about enable ops knowledge from experts? So yes, Red Hat team are the experts, the community are the experts, and they publish the operator, and Kubernetes and Red Hat certify these operators. Encoding, automating ops knowledge, yes. Earlier, the legacy world is reactive, right? Something failed and you were going and fixing it. Please understand, if you are thinking that you are getting into a job to fix somebody's problem, that's not OpenShift. OpenShift is more proactive, right? So you will not find a lot of incidents in OpenShift. If that is happening in your organization, it's a wrong design. So please question your architect. Otherwise, you'll not find, so the operators are meant to, get your work easy, not going and fixing reactively. How the operator maturity model works? Yeah. Basic install, seamless upgrade, full life cycle, deep insight, autopilot. So on air, you want to do upgrade without even a fraction of seconds of outage, right? Then Red Hat gives you the matured operators, which is autopilot, and you can completely rely on it. But as an organization, you are building your own operator. You need to follow this operator maturity model. Please do an assessment of your operator framework also, right? So this is for the architects who are joining this session. I talked about operator. Those who are getting into the development, they can use Ansible SDK, Go SDK, Helm SDK. You can use any of these SDK to build your operator, right? Uh, I have come across guys, those who are using Helm SDK, and I have also got guys, okay, who use Ansible SDK. So we always follow a mixed track, not something which is of only one. So this is the smartest um, you know uh, reference architecture. So if you are comparing Kubernetes with OpenShift, then you understand that the layer which is saying OpenShift container platform, where it is giving you service mesh. So we will have a session on service mesh. We'll have a session on CI/CD. Please have your time blocked for the future sessions. And we will also build cloud native apps. I have a session for this, so please hold on to that. Okay, we will do API management. We have 3 scale API, so we will use API management, and we have a database, AI ML. So we will use Open Data Hub, iVentura, our own product, which is hosted on Open. We will use data services, operation, and we will also do S2I and developer experience, on OpenShift. These are all separate sessions. Please understand, these are separate sessions we are going to do. Today we are focusing more on administration, right? So this is more on administration, and we will continue to do that. Okay. Immutable operating system for container. Yes. Why CoreOS? A lot of people might have asked this question. I don't know if you have asked this question. I didn't see a lot of your questions related to CoreOS. Was there any questions related to CoreOS? CoreOS. Okay, so Mohammed, you have a very interesting question. You say that I have a vSphere under one data center, and what if the whole cluster goes down? Okay, that's like power outage. Huh? Whole cluster goes down means what, Mohammed? You will have a power outage. You have only one UPS, and whole VMware infrastructure goes down and your cluster goes down, right? Okay, what will happen? You should have another data center. So in a lot of bank, what we do is we maintain a cluster in other data center, and you have LB, F5, or the hardware load balancer, which will actually switch, and you will have OCS, the shared storage, either from NetApp or Dell, and you will have OpenShift container storage, so that the persistence of the applications are achieved. That's how the
And
container.
most of data center built like this, right? DR and DC, and DC is not in the same location. It is in another location. Cities may be same, but
Yes, most of
location is
the
different.
data centers are meant like this, but within the data center, can you maintain HA? You can have HA, maintain multiple, leaf switches connected to spine, and have multiple worker nodes spread across multiple rack, so that your power distribution unit of maintaining multiple power supply onto the data center can also be managed in a perfect architecture. Unfortunately, in India, the government, I should not talk about that, but some of the data centers do not follow those kind of design principle, and they have a single point of failure. That means OpenShift is not bringing single point of failure, but the data center is bringing single point of failure. If you want to overcome that, and you want to have a DR in public cloud, I have seen organization on-prem OpenShift and public cloud OpenShift, like ARO. We are a ARO partner. We can help you to design your ARO cluster on Azure, which is Azure Red Hat OpenShift. Your production can be on-prem, and your DR can be on the public cloud, or it can be another data center also. Okay, question related to CoreOS. Yes, a lot of people might have got this thought that, okay, why do I need to go for CoreOS? Because Red Hat Enterprise Linux is so popular, and CentOS, and some people have moved out of CentOS after that myth, that, okay, CentOS is no more supported. But please understand, Red Hat CoreOS is being customized for cryo config, kubelet config, registry, and SSH config. So that makes you, more stable OpenShift container platform hosted on CoreOS, right? Day one OpenShift install, day two is operator. So when you are planning for OpenShift install, how will you plan your installation? We will discuss that on a specific topic, but We can talk about the prerequisites today after we have the demo. So this is something which people ask: what is day one and what is day two, right? So whoever is on the job, please understand, when you are applying for the job, the tasks which are managed, right, by the OpenShift installer and operator are marked in red, and the day two operators are the ones which is actually marked red, and the gray are the user managed. That means, okay, later you'll be managing the the other tasks. Container native storage, I'll have a specific session for container native storage. So OpenShift container storage, OCS. Okay, can I have OCS across multiple data center? Answer is yes. Can I have OCS across multiple node? Answer is yes. And how the container storage works, you can have Ceph as the backend, or any other storage appliance as the backend. NetApp has got appliances also, but that needs a specific design. And why administrator need to learn the container storage? Because the persistence, right? If you need to bring to the application, you need the config, which is like your storage config. It's called claim, and the volume. So claim and volume can be handled dynamically. Container native storage. Ajay, would you like to add anything?
Hi Deepak, yeah. So, with the help of container native storage, you can run your CNA related plugins on each node, right?
Yeah.
If your container related plugins are added to your OpenShift cluster node, whatever the OpenShift stateful pods, that is pod with storage that you are running on the cluster, it will be easy to integrate. Let's say there are plenty of container network interface plugin are available in market. If you switch to AWS, you have GP2, that is general purpose block storage as a CSI, and you have EFS, elastic file storage as a CSI. Those container storage interface plugins you can easily install in OpenShift and create your storage blocks or storage files based on your application requirements. So it is automated, and within a couple of clicks, you have a storage will be integrated and expanded.
Good. Uh, so now can we do the demo, Ajay?
I have a question here actually. In OpenShift, for example, containers are lightweight. If you take into pod and if you take any application, they are lightweight. That is microservices supported by Microsoft. So, for example, if you want to install Oracle database as a Oracle database, if I want my application to access the Oracle database, can that be containerized? Uh, Ajay, did you have got a chance to work on such environment where we can containerize an Oracle database, because Oracle database size is huge initially, and it doesn't come. I feel like it doesn't come to the lightweight architecture. So, and for persistency also, when it comes to persistent storage as well. So we whenever we have different storage classes available. So for that, which is the best option to choose for persistency? Like we have persistent volume and persistent volume claim, right? So this, can you answer my question on this?
Yeah, so basically we have if data is huge, right? If data is huge on your Oracle database, so it's better to keep the database as a server which is outside of OpenShift, and integrate the Oracle database to your OpenShift application. So as the data is huge, because if you are running the Oracle database as a pod, right, you need to manage the storage, the huge storage also you need to manage here.
Correct.
So frequently average amount of storage, it is good to have in OpenShift, okay, as a stateful application. If
Yeah,
data is
so to answer in an architectural principle way, if you are going with a distributed database, right, the new age databases, I would suggest you go for containerization, the RDBMS, right? No doubt, you can containerize, and you have other RDBMS. Oracle acquired MySQL, so you can have MySQL, database and Oracle, but don't expect a VM like behavior of the database on container format, right? So these are all education topic. You should do search why traditional databases you should not containerize. The similar example is WebSphere, right? WebSphere middleware.
Yeah, correct.
So first thing is, what is your time to I talked about self-healing, right? And
Correct.
when something goes falls sick, it actually recreate. So how much time you have got for the new pod to be created? Can you wait minutes?
Mm-hmm.
Several
Oh.
minutes you cannot, right? So
Mm.
so it has to be lightweight enough so that it can be created instantly, and a persistent volume can be attached, right? So volume
Correct.
keeps
Correct.
the data, and your pod should come up instantly. So you should not be going with the images. Again, I'm saying the container images which are very very heavy, right? And it takes time to boot, right?
Mm. Correct.
And they are not most suitable for your modern applications. These are architectural principles,
Mhm.
right? So can I squeeze a big elephant into a small container?
Yeah,
You
no,
can do
it's not
so.
possible. That is
Okay.
why I got it out,
Yeah.
because being a database admin, I got it out like how can we use this approach in real time?
No, you have a very valid point. So databases, middleware, okay, you have to choose what to containerize and what not to
And
containerize.
then I say correct.
Can you containerize? Answer is yes. Till the time you have the image available, right, in the registry, you can create a running instance of that. But when you are recreating it, how long it takes, please understand that. Okay.
Correct. Correct. Thank you.
But we have come across these scenarios a lot. Okay. And then we have done it. Ajay, over to you.
Yes, Deepak.
So
So
can you open a lab?
yeah, I'm sharing my screen.
Yeah.
Is my screen visible?
Yes.
Yes, Ajay.
Yes,
Okay.
Ajay.
Thank you. So, as Deepak discussed, as Deepak highlighted, OpenShift is a smart Kubernetes platform, right? So let's have a quick overview of the cluster. What are the components it has? So basically, OpenShift dashboard has a two portal. One is the administrator portal, and next one is the developer portal. In administrator portal, you can see all the administrator related resources like networking, storage, computes, monitoring, and workloads, right? And you can do a user management for your users as well as application service accounts. And we have some advanced OpenShift core administration, the cluster settings, cluster operators, custom resource definitions, right? All the options are available in the administrator portal. If we quickly switch to developer portal, so here you can use the config maps that you can create, add your config maps and inject to your application. There is a topology, so it provides plenty of catalogs here. So I think it is loading up, and we have monitoring, and you can search your deployment or any OpenShift Kubernetes resources in the search catalog. So let me give some time to and you can switch your your project over here. So as it is loading, let me just duplicate the tab.
Ajay,
Yes.
yeah, will you be able to explain on the command line mode as well for the
Yes.
scene?
Yes. Yeah,
Yeah,
we can
okay.
do that. I'm just shifting to command line mode as it is taking time. Okay. So if you want to list what are the nodes available here, you can run a command oc get nodes. If you want to see what are the cluster operators has been installed, I mean has been available here, you can run a command oc get cluster operators. Okay. And you can see what are the projects has been created. So currently, I logged in with full privileged user, so I can see all the resources which was available in this project. Okay, so we have a custom resource. Let me show you. So we have a very first operator called authentication operator. So what this OpenShift authentication operator basically is doing is it is managing the user identities which was integrated here, and also it is managing the authorization for that user. Okay. So in order to achieve that, this authentication operator is watching some custom resource. So let me describe what are the custom resources, what are the namespaces, what are the services this particular authentication operator is describing. So if I go here, if you see, it is managing a namespace called OpenShift Authentication, and it is referring to OpenShift config namespaces, and we have API versions that it has OAuth APIs, OAuth OpenShift. These are the API versions and resources it has. So let me just do OC get OAuth, like how I did OC get node. I can do the custom resource OAuth using OC get command. If we do OC get OAuth, there is a cluster has been created. So it has all the configuration for your authentication and authorization. So let us see the YAML view of this cluster resource, you know, of this cluster instance. So let's skip this part as of now. Let's refer only the specification. What are the specification tasks? So as Deepak said before, OpenShift support multiple identity providers like HT password is one type, LDAP and GitHub authentication, GitLab authentication, OpenID Connect. So there are plenty of authentication available. So HT password is a kind of a basic authentication provider where you can use. Let's say if you have a Linux machine, you have HT password is installed. You have a tool that is command line tool called HT pass WT. Using that HT pass WT, you can generate a user identities. That is users credentials you can generate. So I have generated, two user identities. That is one for Deepak, one for user Ajay, with encrypted password. Okay. So let me see whether the cluster is coming up or not. Okay, fine. So as it is taking time, let us do our operation, uh, in HD password. So, so here, if you see, already one HD password identity provider is created with the name HD pass secret. So you can list what are the users are available in this cluster using OC get users command. You have two users. One is OpenTLC MGR and one is user one. They are belongs to HD password provider group. Okay. So let us generate two user. So let me check whether I have HD password tool here or not. Yeah. So the command to create HT password user is uh, so users.ht passwd. You can mention username is Dave, password is Dave. So it created, okay, so let me make a directory. I'm just changing the directory to here. So what this command is doing, it is creating a text file called htpasswd in the current directory, and it is adding that user identities. That is, username is Dev, password is Dev. So it created in the new directory. You can verify that encrypted, password. So in the same way, I'm just creating another user. Okay, this time I'm removing the flag because already flag bit C, because already users.htpassword passwd is created. Okay, let create a username called admin and password is admin. So if I reread the users.htpasswd file, so here you have Dave and admin users credentials has been created. So in OpenShift to manage configuration, we have a project called OpenShift config. So already we have a HT password as a one identity provider. Okay. So that identity provider is looking for the secret HT passwd secret. Okay. So let me create a new secret. So OC create secret. The secret type is generic, and I'm creating the secret from file because I have the secret contents will be stored in the users.htpasswd file. So okay, I have to mention the secret name. So let's take the secret name is htpasswd demo.
Ajay, what exactly we are trying to accomplish here?
So we are creating two new user identities, and we are
Okay.
integrating these two user identities to OpenShift.
Okay, so did I talk about RBAC, role-based access control? Because
Yes.
access the cluster, you either need to have a user which is HTTP password based, or you must have an authentication with LDAP or
SSL.
active directory. So what we are accomplishing here is accessing the cluster using HTTP password.
Yeah. Thank you, Deepak.
Okay. Yeah.
So we created the secret. Okay. So let us use this secret for a new identity provider. So as I said, that authentication will be managed by the custom resource OAuth. So let's edit this OAuth. Our secret name is htpasswd.
The same thing you can do graphically.
Yes.
Ajay is doing it command line because somebody asked, okay, hey, can you show command line? So you enjoy the command line, he will also show you graphically.
I'm just replicating the same configuration, but name and provider name will be different.
So those who do not enjoy the command line, just hold on. We'll show you graphically.
So now our file data name is htpasswd demo. So here only our users credentials will be stored, and provider name, let's use different name. Demo login. Okay, and the type will be htpassword.
What is the mapping method claim is there, right? Okay, so do we have only one type of that actually, or else because I know that we have only one type, but do you have any other types or like to understand?
Yeah, I think we have only one type claim. That is one of the configuration for this identity provider API.
Okay, okay.
So let me edit it. So OpenShift, a new credentials has been added. That is one is admin. Admin is one username and password, and the next one is a Dave. So now I am logged in as a OpenTLC MGR user. Let me log into admin user. So it is it is asking my credentials. Let me add the credentials that we created newly. So just a second. Just checking whether I have mentioned the correct secret or not. Okay, so let me change the old one that I created to make sure I'm able to log in or not. So something is happening. Okay.
I think you have to replace it, right?
Okay. So for to showcasing the RBAC functionality, let me use two users here. Okay. So let me try to log in with user one. I think some yes. So for RBAC, functionality, we have two users here. Okay, OpenDLC MGR and user one. So this user, you can say it's a new user. He doesn't have any access to list the nodes, right? So let me relog into OpenDLC user. So let us see in a command how you can provide a full privilege to this user one. So the command to provide a a full entire cluster role to a user, you can do OC policy, add cluster role to the user, cluster admin for user one. Okay, cluster role to user. My bad. Yes. So cluster admin role has been binded to the user one. Previously, as you've seen, is not able to list the nodes. Now let us log into user one. See, previously you got a message you don't have any projects. You don't have access to any projects. Now you got a message you have access to 60 projects, 68 projects, right? You can do all the cluster admin activities like if you have a cluster admin privilege. So you can see what are the nodes are available, cluster operators, the status, and all the things you can do. So in the same way, if let me log into another user that I have, that is user two.
Here I have a question.
Mhm.
If I forgot that cluster admin password, how can I get back to that user?
So here there are three aspects. Okay, so sorry, two aspects. The OpenShift support the HD password authentication. That is one
Yes.
thing that we need to save it somewhere securely. Next is your LDAP. You in your organization you might have a LDAP authentication, right?
Yes.
So
Yes.
OpenShift for authentication for login purpose, it refer the LDAP identities. For authorization only, it will refer to the OpenShift authenticator operator.
Okay.
So I might have entered the wrong credentials. Let me re-enter the credentials. We logged in, to the user two. User two also doesn't have any access. Let us give a project admin access to this user.
Ajay, is your cluster UI is up? Can you check?
Yeah, cluster UI is
Yeah.
up. Correct.
So can you please follow the graphical one, because there are a lot of new people, and they must be wondering, oh, so complex commands, right?
Correct. Sure, we can follow.
Yeah. So you switch to the user which you have logged in, or you wanted to log in and give the privilege graphically.
So currently I logged in with a full privileged user. Let me open a incognito window, and over there I will log into a new user. So before this opening up, let us assign a role. So we have a user management catalog here. So you can create a role binding. So role binding is basically your there are set of roles has been created in OpenShift. You are binding that role to the user. That is basically a role binding. So let us create a binding. So there are two specific. One is namespace specific, that is project specific. In project wise, you have administrator. In project wise, you have user which have edit role. In project wise, you have user who is going to view the resources. That is namespace role binding. And next one is a cluster wide role binding. This you are providing a cluster level access, cluster wide access to your users. So in a command line, we have provided cluster wide access. So let us give a namespace specific role bindings here. So let us mention a names role. This is a friendly name you can give. I'm just providing a user to admin. And what namespace? It is asking us to fill which namespace this user can access. Let's choose a namespace called CICD. Okay. And what role you want? There are plenty of roles available. Let us take an admin role only to this project. Only to this project CICD. Okay. And it is a user. You can do it for a group or application service accounts. So I'm just entering the user too. So let us log in now. Yes. User two is logged in, and So currently this particular user doesn't have access to any projects. You can see the project list we are not able to see here. So let me give access. I'm just providing access to the CI/CD namespace as an admin for this user too. So let's create it. So role binding has been created. Now let us go to the user 2 window. You can see on the fly project CI/CD user 2 can see. Also you can go inside the project, right? So you can see what are the workloads that are available in this project. So as it is CI/CD, I hope we have a Jenkins instance might be running. So as the user have a full admin privilege for this particular process, for this particular project, he can delete the pod or he can recreate the pod. So what all the operations he can do in this project, he cannot touch other projects. So this is one of the best or bad case.
Ajay, there is a question how to list all master node components. So,
Sure.
can you list all the pods running in a master node?
Yeah, we can do that. So we have workloads pods are running here. So let's choose for all projects. So the project count is huge here because in this cluster we have 250 plus pods are running. Okay, so you can do a filtering based on set of resources. Let me show you another option. So there is a compute. You can you can list what are the nodes are available. Let's say we have a master node. You can log in, you can enter the master node. There is an option to list the pods which are running on the master nodes. So it's loading up. Yeah. So these are the pods which are currently running on master nodes. So we have covered this RBAC. So any questions on RBAC, guys? Okay, so if you don't have any questions, I think we are good to move to next topic, that is managing OpenShift nodes. So this is a cluster which is deployed on a multi-availability zone on OpenShift, sorry, on AWS. Okay, so there are two objects here. Okay, one is the machine set, which helps to manage the machines, and next is some machines which is closely integrated with your nodes. So basically if you list the machine set here we have 6 availability zone, that is USG is to 1A 1B 1C and up to 1F, right? In 6 availability zone you can see how many machines are running. If it is a machine, this is the AWS instance, that AWS instance will be your OpenShift node. Okay, so if you see here you have two nodes are running, that is 2 AWS instances are running. So let's say if you want to add one more node, right, you can directly click this machine set, and there is a option to scale the node. For a manual scaling, you can just do you can increase the count. So once it is saved, machine set will instruct machine to create a new machine. So you can see one of the new cluster worker node has been started provisioning. So this is actually provisioning a new EC2 instance on AWS. Okay, so that machine set has all your AWS metadata, that is which VPC, which subnet, what are the security groups needs to be used, all the things this machine set has. So using that idea, it started creating a machines. So previously we have seen it is in a provisioning state. Now it is provisioned, right? Might be node is booting up. So how you can see in OpenShift full stack, based or cloud-based OpenShift cluster, how easy to scale a worker node or how easy to add a worker node, on your flavors. So currently you can see here around 5 and yeah, totally it has 10 nodes, 10 machines. So once this machine is turns to provisioned as a node, then that machine will be added as an OpenShift node in this section. So let it provision. So as it took around 2 or 3 minutes, let us quickly see some cluster settings. Okay. So this is one of the best feature in OpenShift, seamless upgrade. So you can upgrade like your mobile application as an entire cluster, as an entire under node cluster also. You can upgrade in a single click of button. So it will provide you an upgrade path. The current version of OpenShift is 4.7.4. Here itself, it will support which version you can shift to. If you click update, so the upgrade will start from 4.7.4 to 4.7.12. So this is a basic overview of your cluster ID and all. And in the next step, we have a cluster operators. So these are the cluster operator. You might have remember we ran a command OC get CO or OC get cluster operators in the CLI. So in GUI you can do the health check of your cluster operators in this version. If it is in available state, then all the backend components for your authentication is in running. In case if something has happened to your OpenShift authentication pods or OpenShift authentication secrets, so you might not see it's available. It should be in a pending state or progressing state. So as we created a new AWS instance for our OpenShift node, let us see how it is creating in the CLI also.
Okay, so how many of you have questions related to how the worker node scaling happened, and it was so seamless? And some of you have asked why a lot of production cluster runs on AWS or in private cloud, on top of OpenStack. Um, so it need not be on top of OpenStack or in a public cloud. It can be on VMware also, or it can be on Red Hat virtualization KVM. But remember that it has to spin the VM as a worker node and add it to the cluster. So that is being taken care by the operator.
So you can see the machine that we provisioned, that we scaled, which is 3 minutes ago, has been in a running state. Let us check whether it is added to a part of OpenShift cluster node. So you can see 32 seconds ago, a new node has been added to a part of cluster as a worker.
So that's the power of operator automation, where you don't see any outage. And if you are running a production workload, as you see here, it is a big one, where we have 6 worker nodes and multiple availability zone. Can you just show the multiple availability zone?
Yeah. So here we go. So we have 6 availability zones.
So machine sets are the configuration where we define the limit, and machines are the runtime.
Perfect. So
Manoj, we just did a demo how to scale up the worker node. We increased the count in the machine set, and that increased the machines.
see, we are getting a pod scaling feature in a node level by seeing this.
Yeah. So last time we did pod scaling using replica set, correct, Ajay?
Exactly.
And this time we did node scaling.
Correct.
Yeah, Ajay, what else?
Sure. So during Deepak's description, so we have mentioned a SSO operator and what are the objects needs. So let us see. Let us install an operator that is Red Hat.
Okay, so you are now showing us the operator. Fantastic. So which operator, Ajay, you will do? Is that key clock SSO?
Exactly. So that's what I'm planning to do, Deepak.
Cool, cool. So we will launch a SSO just within seconds.
Yes. So first, let me create a new project. Okay. So the
Just
project
a minute.
name.
So why pods are running on the master?
Hey Sriram, I explained. Pod is the the new definition of containers, and OpenShift doesn't operate without pod.
I
So your
understand. So the pods will be running on the worker nodes, right?
application pods will run in a worker node.
Hmm.
But all these features, Sriram, we talked about, what are those? They are services. They are also pods. They are master pods, right? Application pod, if you have a web front end application, back end application, that you will run it in the worker node. Like Ajay is going to launch a application that will run in worker, right? But your core services, the Kubernetes services, where will it run? It will run in master, right?
Yes.
Right.
I gave you a document. I pinged you a
Yeah, I'm
document,
going
so
through the
just go
document.
through that. Yeah. Thank you.
Sure. If you see a OpenShift operator catalog, you have a countless operators for various items. That is AL and MI and big data, database, logging and tracing, monitoring. So all the flavors you have also for CI/CD. So currently, let us install a SSO operator. So within a couple of clicks, you will get a SSO operator should be installed on OpenShift. So before installing this operator, I just need to give a quick prereq for SSO. If you want this kind of a production based or standard SSO on your Kubernetes platform or OpenShift platform, so the SSO need a database to show the metadata, that is Postgres database. And to secure the sensitive information on SSO, that is single sign-on, we might have create a OpenShift secrets to add a SSO DB credential, that is a Postgres database credentials or SSO admin credentials or SSO user credentials that we will be keeping in a secret. And SSO configuration. So the configuration for SSO will be adding as a OpenShift config map. So you can choose here also, you can change your namespace. As I created a namespace SSO, I'm just I choose clicking that namespace and started installing this operator. Also, you can see what are the APIs that is provided. It provides key clock relim, and all key clock related services. This operator is providing. So let us do an install. So operator has been installed and it is ready to use. You can click here to see the operators and their operator dependent APIs. So if I click here, there are it provides what are the APIs this operator is providing. Okay. So before that, let us see what application pods are available in this project SSO. Okay, as it is taking time, let me see from the CLI. So currently we have one microservice or one pod, that is RHSSO operator. Okay, it is waiting for the API should be spawned. So let us choose SSO here. As we have seen in the CLI, we have the same SSO operator pod is running. So let us create a one instance using this operator. So we have a key clock instance is a catalog available. So let's create the instance. So there are two views. You can, if you want some additional key clock related configuration, you can pause in YAML, or if you want more user friendly, you can choose form view. So I'm just creating a name called key clock or key clock demo. Okay, and it provides if you want external database that you can use it. If you skip it, it will provision a database and add it here. So these are other key clock related specification. We can pause it. So let us create it to see what are the services it is creating. The key clock demo is created. Okay, if I switch to pod, so as I said, key clock need Postgres database. Postgres database is started provisioning, and key clock application pod, that is key clock 0, some metadata has been created. So this key clock Postgres need a storage because as it is a database, we need to persist it, right? So you can you can elaborate the storage here and see whether the persistent volume climb is created. So persistent volume climb is created, and it is using this PV, that is general purpose AWS CSA driver. And if we go here, so the two pods of key clock has been running. Let us refer whether the required secrets has been created or not. So there are credential secret which is needed for key clock, and key clock database secret. Those secrets also created, and few configurations which are needed for key clock application also been created. And we also this operator exposes this key clock application to outside world. So we have OpenShift routes here. So you can see a route has been created and it should be secured. So let me access the key clock application. So I think it is it's still starting. Let us refer the pod logs. See, it is not yet ready. So a container is started, but it is waiting for a required service needs to be come up. Now it is one by one, I mean a ready state. So now we are good to reload the page. Yes, it is starting up. And we have administration control for console for this key clock application. Now we need to know where the credential is. As we said, credentials has been stored in secrets. So let us refer key clock demo credentials, secret object which is created. You have admin username and admin password is created. So let's reveal it and take the values. I'm just hiding it here. So admin is my username and password is the data that they copied. The enterprise single sign-on portal has been deployed as a container, and we have access. So using this, you can you can use SSO for your application authentication or application payment gateway. A lot of use cases, you can do SSO as an add-on. So this is how operator installation will work. So let us refer the same from the CLI. So here our custom resources are key clock, OC get key clock. Instead of OC get pod, you can do OC get key clock. The key clock demo has been created. If you want key clock demo one, that also be created using key clock custom, OpenShift resource. So any questions, guys?
No, interesting walkthrough. I think the practice is needed, but understood like how ease to launch an operator and how can we configure that. Thank you so much, Ajay.
Great. Thanks, Sean. Done. So not only for a single namespace, not only for a single application. So operator is much more powerful to manage multiple namespaces. If your application wants 2 or 3 namespaces, that also you can add your operational knowledge into an operator image. put it into upload into Operator Hub, run your application at scale. So any questions, guys?
Sorry,
Okay.
Ajay, you there?
Yes, Shiva.
Do you have any example related to networking related operators?
Yes, our OpenShift underlying network itself running as operator. I will show you a quick around quick workaround.
Yep, go ahead. Thanks. Yeah.
Oh yeah, as Deepak has mentioned, here we are using this OVS stuff and all. So are we using anything else like third party like CNIs, like Calico, whatever, which we use in
So
Kubernetes?
we are using a CNA called Multus.
Yeah, I will do one session on Calico. So me and Ajay, we both are working on Calico. When do you need Tigra Calico, and when you can live with OVS? So always, try to understand things architecturally. It's not about somebody is asking, so I will go and get it done. No, you should know why do you need it.
Exactly. That's my question as well. So if anything, product by giving by itself that capability, right? So without going to any
today you would have understood, okay, why OpenShift, why not Kubernetes? Right? Kubernetes brings everything, right? But you need an enterprise grade, cluster management where your production is, heavily relied, right? And you cannot take chances of, outages onto the cluster because of a wrong design, wrong product configuration, wrong patch, those things. So you require OpenShift, and these features which you saw, like, okay, the operator, certified operators, the UI, the fantastic UI, what you are experiencing, where you are doing all cluster administration. We will also do developer. So on the top, you have a role change, right? Okay, you can become a developer, and you can do things. But the question here is, when we are talking about any new integration, whether the integration is, I think we also talked about what authentication integrations you have. Ajay told about HT password, which is the default one, was the basic one. So LDAP, I think somebody posted, the config LDAP. You can do GitHub, GitLab integration. LDAP. When I say LDAP 3, that means it all goes all the way to all category of LDAP products which uses LDAP 3. Similarly, on the network side, if you have the SDN being managed by OVS, why do you need Tegra Calico? Right? So ask this question and come back in the next session so that we can do a session only for Tigra Calico CNI or any other SDN CNI, because I'll just give you a hint, like BGP, use case, right? Okay, why do you need a BGP use case in an enterprise environment, right? Somebody asked, I think that Vijay asked, can I run database in container? And Ajay said, okay, why don't you keep the database in a VM, right? So now your application is running in a container and your database is on a virtual machine. Then how will you connect the application and database seamlessly, because they are in two different network, and then how that routing will happen? Can the database talk to the application, and can the application talk to the database without using NATing, right? Without using NAT. So that is where we can discuss about Tigra Calico, right? So we will come up with those topics.